Good afternoon, everyone. Welcome. We are very excited to bring this next topic to you. I'm Nick Limère, Head of Advisory at ML6, and I will be your moderator for today. We're witnessing a fundamental shift in how humans interact with technology. We are moving from clicking and typing into a world of conversation. And so the thesis of today is very simple. Voice is the fastest path from intent to action. And finally, the technology is reliable enough to give it to your customers. But first, I'm going to introduce the speakers of today. At first, we have, in our partnership with ElevenLabs, Thomas Ränke, Head of Partnerships in Europe. Thomas sadly couldn't make it in person today, but he is calling in from Berlin. Welcome.
Thank you. Welcome.
Next, we have Jens Crokaert, AI Project Lead in Voice Projects at ML6. And then also another colleague from ML6, Ryan Ott, ML engineer and a lot of experience in bringing those AI voice projects into production. But something went wrong already. Ryan, I see you're wearing a white shirt. You should have been wearing a blue shirt. What went wrong?
I know, Nick. Yeah, I was really looking forward to that blue shirt. I was supposed to be wearing that today. Let me actually call the store to see what happened about that. Okay, let's see.
This is Novamart support. I can help with order status, product, or returns
questions.
Hey,
Novamart support. Yeah, I'm wondering where this blue shirt is that I ordered. It was supposed to have arrived yesterday. I'm in a nice webinar and I still can't wear my shirt.
I'd be happy to help you track down that blue shirt. To look up your order, I'll need your order number. Do you have that handy?
Yeah,
if you have the
that'd be 187. Then I believe it's 4 fours after each other, and then 670.
Got it. Let me pull that up for you. Based on the shipping preferences you've shared, we had it delivered yesterday to your neighbors instead of your address. Have you checked?
Right. Yeah. Okay. Sorry. My bad. That's on me.
Okay. No blue shirt, but at least we heard our voice agent in action already. Let me first take you through the agenda of today. All right, the first topic, Jens from ML6 will break down the 5 engineering challenges like latency and barge-in that cause most voice pilots to stall in production. Next, we're going to do a roundtable on what makes great voice AI. We'll shift into that panel discussion with Thomas from ElevenLabs on how best-in-class voice models tackle naturalness, tone, and customer expectations. Afterwards, Jens will take us through the business cases for voice AI. He will present a practical KPI framework based on real-world customer use cases to show you how you measure true value. Afterwards, we have Beyond Automation, Voice as a Brand Asset. Thomas will explore why your voice agent's personality is a core brand asset and how you design that. And last but not least, Ryan from ML6 will lay out a practical, phased maturity approach, keeping those guardrails, security, and timelines realistic. Afterwards, there is also a Q&A, so make sure to put those questions into the chat, and we will tackle them at the end. But first, let me also introduce ML6 to you for those who don't know us yet. ML6 is an AI-native market leader in Europe. We do that with over 130 experts in 5 offices, and we have a proven track record into getting those AI solutions into production. We could talk much more about all those different projects and the time that we spend on research. However, today we would like to focus on another aspect of ML6 that really differentiates us. And that is our partnership ecosystem. We have a very broad ecosystem of partnerships supporting that agnostic view that we have on technology. We have partnerships with all the big hyperscalers. We're also collaborating with Cisco on cybersecurity. But for today, let's focus on 3 specific ones here. Back in June, ML6 was one of the 6 first official worldwide partners of OpenAI, and 1 out of 4 in Europe, being chosen after a rigorous selection process of our engineering capabilities. And just last week, our official partnership with Anthropic, known from the Claude models, was announced. A further confirmation of our reputation and capabilities on the European market. And last, but definitely not least, our partnership with ElevenLabs, the leading voice AI company in the world. and I'll let Thomas introduce that to you.
Thank you so much, Nick. And also welcome from ElevenLabs. And thank you so much for the partnership, ML6. So my name is Thomas. I'm leading go-to-market partnerships for ElevenLabs in Europe. Our goal at ElevenLabs is pretty simple. We want to make AI sound human. And we've started with building out the best and most accurate voice models, and now offer our customers, on top of that, 2 products that help them transform the way they communicate with their customers. We have grown in the last 3 years to over more than 600 million in ARR and support more than 75% of the Fortune 500s and some of the largest companies across Europe. Now, as mentioned, the foundation of ElevenLabs is our research. So we are working every day on providing our partners and our customers to offer both the most accurate speech models and the most expressive text-to-speech models. And we help our customers and partners to turn this research into value in production by offering 2 products on top. One is our agent platform, which helps our customers to create, optimize, and scale voice agents across all consumer-facing channels in more than 70 languages, as well as our creative platform, which helps our customers to create and localize audio and video content in more than 90 languages. And with that, I hand it off to Jens.
So before we can dive into the use cases and the business case behind voice AI, it's also important to think about some key complexities when designing it. Nowadays, we're living in an instant resolution economy. Customers have become impatient and are used to being served well, but also fast, and only accept first time right. When I'm hungry, I want Uber Eats within 30 minutes to deliver my food. When I'm out of toothpaste, I want Amazon to deliver it the next day. And when I have a question, I want an answer right away. There's the importance of good service, yes, but it also needs to be delivered now and fast. And a customer might leave the customer journey if not. Speed is definitely become a part of brand experience. I'll pause here for a second, and I can imagine you thinking, who writes like this? Obviously, no one, but we do talk like that, or at least that's how a voice AI receives it often. We see, for example, that my name might be pronounced wrong, because you know it's Jens by now. I might also be using some slang. First, I'm talking about a credit card. Later on, I'm talking about a debit card. We also see a dog interruption and somebody correcting the dog, and there is a lot of hesitation and latency, while also the notion of time is captured in a slang. However, we still expect, and voice is still able to capture the name right, also understand that we're talking about a debit card and correct the timeline and the caption of or the notion of time that we're talking about. And it shows some of the complexities that we're having. For example, when texting, I can be searching through a document to collect my identification number, then send a text, wait for a second, and the message can take a second to get back to me. Whereas in voice, there is no room for latency. Studies have shown that a delay over 500 milliseconds is unnatural. It's awkward, and there is the risk of user collision. There is a challenge that we should deal with, which is dealing with real-time streaming APIs. Secondly, we also need to make sure there is a high-performance orchestration layer to make sure that the time to first output of the model or time to first token is minimized. Secondly, there is the reality of sound. Nobody knows you're in the business, a busy doctor's office, or that you're jumping on a busy bus when texting. However, in voice, it is all heard on the audio. Second thing, nobody types in dialect. While in talking, it is the case, and not all standard models are able to deal with that. Next to background noise, there's also the complexity of poor mobile reception. So next to having a high-performing model that should natively tackle this, there's also the importance of confidence scoring, when the model should indeed mathematically give a score to this confidence that he has in what he understood. And if unclear or the score is too low, he should ask again for clarification to the customer. Next topic is handling natural human flow. Nobody's typing in text. People don't change their mind mid-sentence if they're texting, but you do when talking. And if you check on ChatGPT or a lot of voice bots, you're actually restricted, visually restricted in sending again a new request while it is computing and giving you an answer. While in voice, there is the need for full duplex. It should listen while it is speaking, and there is the possibility of barging. You can interrupt it, it should stop, include your new message, and completely change the process and pivot without losing the context of the whole call. There is also no visual anchor in voice. When asking ChatGPT something about, for example, a tax policy, you will get a long text with a lot of links. With voice, you don't want to listen to a 5-minute speech. It should think about how we should deliver info in a short, digestible nugget. You need to think about the length, the format, and how you want to bring this message across to a caller. That's why voice and voice user experience design is a specific, separate discipline. Next topic, of course, is also the architectural layer on the back end. Voice requires an additional specialized architectural layer that must be seamlessly integrated with the existing customer experience or channel layer which your customer is interacting with, and then also the agentic layer behind that is interacting with your own data. And then lastly, there is name matching, a specific and complex topic that typically fails in voice AI. The problem, as shown on the left side of the slides, is, for example, Sophie with PH compared to Sophie with an F. If you do standard exact matching, there is often the case that you get 0 results. The bot would loop, customer gets frustrated, and they drop the call. The other side of the spectrum would be that it would be too loosely defined, and then you have a security problem when you would be sharing information with a customer who is actually not the person mentioned in your CRM system. It still is explicitly critical in banking, telecom, and other customer experience environments. How do we solve it? Main solution could be that we do an integration with your CRM system, where we know who you are based on the first information that you gave, like, for example, your national registration number. A second way, if we are not integrated with the CRM, could be to apply a 3-layer cascading matching strategy. 1, we normalize the data. For example, François with a certain accent becomes François without. Jean-Pierre with a space becomes Jean-Pierre altogether. Next up, there is a phonetic matching in a way that Catherine with a C or a K is treated the same way. And lastly, there is fuzzy matching, so that Mertens and Martens all become possible to link and match together, while also taking account that we do a match more on last names, which are more unique than first names. All to reach, on average, an accuracy of 96%, which I think is impressive.
All right, thank you, Jens. We have all the experts around the table here, so let's have a discussion on what makes great voice AI. Ryan, I'm going to kick it off with you. In chat, every message comes across in a very neutral way. However, in voice, a lot of emotion can be involved. So you can hear when people are stressed or pissed off. Is that taken into account?
Yeah, definitely. And I think the most important there is a distinction. So we can look at both the content, but then also the nuance of how a person speaks. So while in chat we only have the content, this also still flows into our decision for the voice model. So we can triage or classify how the conversation should go based on the content. So if somebody's mentioning topics that require urgency or we deem aren't really meant to be handled by the model, we can move the conversation based on that. And then also importantly, what really makes voice stand out is the nuance of it. So the models adapt to how the user speaks, and then they also try to work with that. So somebody who's pissed off, as you say, for example, maybe it helps then if the model is able to detect that and then adjust its responses dynamically to be a bit more empathetic, show understanding. But then also conversely, we don't always go against the customer or the caller. If somebody is really talking urgently, hey, I need answers quickly, it also helps if our model is able to speed up. And we built the models, and ElevenLabs built the models to facilitate exactly that.
Nice. Okay. Yeah. Important part in the decision making of handling the question. Okay. A question to Thomas. How do you tackle the complexity of local dialects? I think I can speak from experience that in Flanders it's a very sensitive topic. The distinction between Flemish and Dutch. How do you guys tackle that?
Yeah, so there are obviously a few elements to that, right? So the first thing is, of course, the training of the models to make sure that we have the right distribution of data across the languages and dialects. And then in the experience itself, what we want to make sure is that the model understands and detects the different languages, right? So that even mid-conversation, you can switch between Dutch, Flemish, English, whatever the customer prefers. And that we also match it to the right voice, right? So sometimes you have one voice that can support multiple dialects, But in certain situations, it might be better to also have different voices that can match the right dialects, so the customer has the best possible experience, right? So we see, for example, here, the same experience with a dialect gets 20-30% higher CSAT scores, right? So there's a huge impact on getting this right. And then finally, what we also do together with ML6 and our customers is to make sure that we get the pronunciation right. So if there are, for example, brand-specific terms, we can make sure that the model understands this and picks this up and can also properly pronounce it. And the last thing is, if we see that there is not a good distribution of the right accent in our voice library, we can also use our voice cloning. So essentially pick up an audio file with the right dialect and essentially clone that voice to then make it available also across voice agents.
Nice, really taking it to the next level on personalization. A question to Jens. You mentioned before something about name matching, but in a lot of calls, I also have to provide like a type of customer number or a number on a letter. How does it handle that?
Yeah, good question. It's a similar type of complexity that we have. Of course, with the models improving fast, like the models of ElevenLabs, they're also often natively able to capture those. However, still it can be complex. And same as for name matching, we're often able to already have a CRM integration. So we know what type of numbers we're looking for, we know what type of format. But even then, there can be very hard cases. If we take the example in Belgium of the national registration number, an identification number that we typically have to give a lot, it's a number of 11 digits, which is hard. However, we know the format. And what we can typically also implement is that the model first does an API call based on the format. It will then check if the number it received and understood is actually 11 digits, and only then it will actually check if the numbers are correct to the ones that we have in the system. That way, the model is working more efficiently. We reduce the latency. If at first the format is not correct, it will not do the full check. And in that way, we're always often sure that it's correct, but also in an efficient way.
All right, yeah. So just like humans, the context around it helps understanding what is being said.
Definitely.
Interesting, okay. Ryan, our engineer. So the models can do a lot. What haven't we discussed yet? What is a complexity that still sometimes occurs?
Yeah, sadly, or maybe not sadly, but the same issues as dealing with humans, really. So we can have long conversations. I mean, I think everyone has come across the issue of trying to schedule appointments with lots of people at the same time, finding time between all the different parties. You can go back and forth a lot of times, meetings get canceled, things could change. So what's difficult is keeping track of all these changes and making sure that you keep the details correct. And I think what we try to do there is try to give the model not too much context. Don't let it lose the needle in the haystack. What we do is save intermediate results and let the model find the details again so that it makes sure that the details still match when it actually comes to scheduling the meeting.
Yeah, so that context has to be managed still. Exactly. It's not just dumping it in there. Okay. Final question to Thomas. How do we train the AI when our policies, products, or promos change? And is training the correct term here?
Yeah, so obviously we wouldn't retrain the AI itself. That would be too slow and also too expensive. So typically what we would do is look at, okay, what type of data is it, right? Is it like real-time data that needs to be embedded into the agent experience? This is something that we would typically plug in through a tool call and an API. So it's never out of date. So this could be, for example, pricing or active promos. And then there's kind of the more stable information like company background information, right? This is something we can just plug into a knowledge base that the AI reads from. And before any changes go live, what we can also do is essentially test and simulate the conversations based on the new information to make sure it's properly used and provides a good experience to the customer.
Okay, yeah, that's great to hear because retraining would indeed be very expensive. All right, we've already answered the 6 key complexity, but now let's discuss those potential use cases that you might not be thinking of yet. So, Jens, take it away.
So like Nick mentioned, now is the moment to go into the use cases and business case behind voice AI. There are multiple use cases for voice AI. There's not just the incoming calls. There are multiple real-life use cases that we typically develop for our customers. The inbound calls, indeed, the calls coming in, the customer is initiating the call. The AI will then answer, will do the identification, and will help with the easier or even more personalized, complex questions. We will dive into that topic a bit more in the next topics and slides. However, there's also outbound calls, where it is the AI who initiates the contact. An example could be billing and collections, reaching out to overdue customers who are typically in a manual process only called once. There is no follow-up because it's too expensive. The cost per call is too high to call them multiple times. However, there is now a way to do this at scale at a very much lower cost per call. Secondly, there's also a combined version. To give you an example, we have medical practices or hospitals. People on one side are calling in. They're calling in because they have questions. And you have to do the intake, while at the same time, if it's a basic question, you might be able to give them an answer. While if it's a more complex question, you need to have an intake, understand the issue, and make sure it's all well documented, so then a doctor can take it up after. At the same time, within the same context, understanding that context and the patient's situation, there also need to be done outbound calls, for example, to schedule the next appointments and scheduling those in with the customer. That's a clear example of a combined use case of inbound and outbound calls. And then lastly, it can be seen as an upgraded version of your already existing and very much desired chatbot for example, frequently asked questions or personalized questions. But it is now upgraded to be omnichannel or even multi-channel and can now fully be used with also the personalized voice capability that actually fits your brand. Now, of course, maybe to pause for a second here, we are not doing this all at the same time from day one. The goal is not necessarily to having all these calls taken or fully handled by AI from the start, as we could have envisioned in some of the demos. That's the North Star. The goal is to bring both your employees and your customers, to bring them along on this journey. The goal is to bring, indeed, all of them on the journey and to support and unburden your workforce of all these tasks to make them focus on more valuable tasks that are more rewarding for them. So on the left side, we see indeed, as in a lot of cases, it's still being fully human-led. We leverage the human capabilities, where you indeed have the empathy, the judgment of a human, which of course can still be at a slightly higher cost. The next step in that process would be AI-assisted. AI support is done by an agent. The intake can even provide some suggestions, can make sure it's all noted down in the CRM for a warm handover. And the last one, maybe the North Star, could be a fully contained call, where there is no handover needed to a human agent, and it's fully taken care of with a 24/7 availability. Now, of course, it can be a journey going from human-led towards contained, but it's not necessarily the case. For example, it could be that there is an ideal mix or an ideal split of the calls over all of these three, depending on the task complexity. There are some tasks that you always want to be handled by a human, some always, or ideally can be contained fully by AI. It can also depend on the intent of the customer, adapting to the urgency that they bring or the reason why they are calling, you want to make a split, or also depending on your workforce situation, as you will see in the next example. So the goal is now to deep dive into an example of AI assistant inbound calls. So an inbound call, for example, that comes in, the AI can here play an assisting role in the intake and the verification, and then look at the waiting time, what could be the next step and the role of AI. To make it more concrete, this can be made flexible to adapt to your organizational situation and the pressure your workforce is experiencing that day. Option one, for example, could be a direct connect. The AI is smart enough to look at your waiting queue, and in this case, we would assume that you still prefer to talk to a human, so we can direct you directly to a support employee if the waiting time is, for example, below 30 seconds, because there is no intake friction there. However, if we would see that the queue is between 1 or 5 minutes, which is something that a user typically doesn't like, then we can make sure that the AI already collects specific customer information, for example, their account number, the issue type, the reference, and the context, and then there can be a warm handoff to the human agent who then at that point picks up with all this information provided without zero waiting time for the customer. And lastly, again, this is often optional, but it could be in some cases that there is an extremely long waiting time, let's say more than 5 minutes. Then we have a situation where the AI can already do a full intake, and as we still want to have a human then actually help the customer, we can foresee that the scheduled callback is being done by the voice AI to make sure that then they get a callback from a human who has then all the information to then start off and where the customer does not have to repeat himself. So again, this is an example of AI-assisted calls. The customer request is still resolved by a human guide in the end, but with a human in the loop, as we like to call it, but also with a warm handoff, as we also typically refer to it. It is integrated with the CRM system of you, the customer, where the human agent then receives a pre-filled ticket in your CRM with all the captured information. From the customer point of view, there is a zero waste time. He does not have to wait in line and is not repeating himself all over again when he's speaking finally to a human agent. From the agent side, he can fully focus on the complex question that he needs to resolve with the customer, that it actually requires his expertise, and he's fully prepared to handle that discussion. So I think the many examples that we've mentioned have already highlighted some of the obvious advantages. To name some of them again, there's no more, it's done with waiting times for the customers. Also, multilinguality is baked in by default. Secondly, a caller never gets sent through to the wrong agent anymore, which is also one of the key frustrations that customers typically have when calling into a customer support center. For example, now based on the intake, we can now actually understand what the customer is referring to. If it was not a frequently asked question and we're not able to fully handle it within the call, we already know that which specific expertise or second line agent could actually solve them and directly in a first time right send them through to this content expert. Then also it is fully integrated with your ERP system and understands the context of your organization and the customer's previous interaction that you might have had with your customer support center. There is, as we mentioned, a seamless handover and documentation of that in your ERP system. And finally, it is all with grounded responses, meaning that there is also not generic answers, while at the same time still having consistency in the answers, because the voice agent is able to look into the data in your system and provide a more grounded and well-informed answer to the customer. So throughout the process, you will be able to measure and see the impact of these KPIs, and also measure it through KPIs and other metrics. For example, there are some concrete KPIs on employee level, because of course it should be something that is having a positive impact on your employees, but also your customers and your business. To name, for example, one on the employee side of things, it will definitely increase the documentation consistency, and this will of course increase further as we go through the line of more AI involvement. It will also reduce the handling time, which is something that is typically very much appreciated by the company, but also the employees, which will then also increase the employee satisfaction. On the more customer side of things, there is a strong KPI that we can reduce, being the answer resolution time, which is, as we said, very important in this instant resolution economy that we're now living in and the expectations that customers have, which will then also increase the CSAT, which is also a very important KPI for the customer support centers. And lastly, from a business point of view, all of these together will, of course, also reduce the cost per call, which we typically see to be, of course, 100% when it's fully human AI-led, could go down to almost 70% of when it's AI assistant, and up to 20 to 30% of the average starting cost when it would be fully contained. So those were some of the key use cases and advantages, and even KPIs to track that. There's one other big and significant, but also innovative possibility that voice AI has that has not been covered yet so far, but it deserves a specific focus, which Thomas can tell you more about now.
Perfect. Thank you, Jens. So with all the use cases we've seen, what we're currently seeing in the market, that it's not only about what is said, but also how it's said. Right? And I think we all remember those times where we just called up a call center and were welcomed by this robotic voice that wasn't really able to understand us, wasn't super empathetic, and didn't really represent the brand. And even more so, what we still see today is it doesn't really matter if you call an insurance company, a bank, or a retail company, most of the voices still sound the same. Right? So there's no real differentiation. And if you remember, for example, the TV jingles in the 90s, right? Like you would hear this ad and through the jingle, you would immediately remember and recognize who the brand is. This is exactly what we're entering with voice agents today. We now have the ability to translate the brand identity into a unique voice for the brand that they can carry across channels, languages, and every interaction with their customers.
My name is Michael Caine. You know, I've played many roles in my life, both on and off the screen. But now, I've got a question for you. What makes a voice iconic? Is it the tone, the accent, the balance? Well, the answer is quite simply the message. And now, through the power of artificial intelligence, we've turned sound into something more. Connection without limitation. Because voices give us strength, power, protest, prayer, and joy. But each new frontier, each new advancement in technology is met with caution. And rightly so. But every single time, the human drive, the passion, artistry, and creativity prevails. Because technology is just the medium. This is humanity, amplified. I am thrilled to announce that my voice and I are joining ElevenLabs. Try it for yourself today.
Yeah, so this is just an example of one of the voices that has been created using ElevenLabs technology. And this is exactly the kind of ambition we also helping brands to bring to their customers. Really thinking about what represents us as a brand. How do we want to show up to our customers? And most importantly, how do we want our customers to remember us? So we essentially give the customers the AI entity tools to create their own voices, to also use the voices, more than 11,000 that we already have in our library, and to also design and recreate just from scratch. So the way it already works today, and we do it together with ML6, as part of this journey, as part of thinking about how can we create a memorable voice experience, we sit together with the customers and literally use a prompt to create a voice that uniquely fits their brand. So just to give you two examples that are just created using a simple prompt.
Arigato ElevenLabs. My blade is ready.
Yeah, so a lot of emotion already.
This is strictly confidential.
And here we can also see the ability to essentially infuse the dialects and accents that we already mentioned before. And of course, it's not only about the ability to create this, but also to infuse emotion. And here's just an example of how we bring this to life with our latest text-to-speech model generation.
Hey, Jessica, have you tried the new 11v3?
I just got it. The clarity is amazing. I can actually do whispers now. Like this.
Ooh, fancy. Check this out. I can do full Shakespeare now. To be or not to be, that is the question.
Nice. Though I'm more excited about the laugh upgrade. Listen to this.
That's so much better than our old ha 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 robot chuckle.
I know, right? And apparently we can do accents now too. Fancy a cup of tea?
Wow. V2 me could never. I'm actually excited to have conversations now instead of just talking at people.
Yeah, so this is just one example. I think in the end, as I mentioned, it's really about understanding how the brand and how you as customers want to show up. We can obviously fine-tune the emotional range of the voices and the way the agents speak to the individual context and to the individual customer. Thank you. And now handing off to Ryan.
Thank you. So Thomas just showed you what your brand can sound like. But here comes the difficult bit. A voice that sounds that good makes people trust the agent quickly. But a working demo and a production agent are far from being the same thing. This next section is about the gap between them and the specific things we built to cross it safely. So what goes wrong when you don't take the right precautions when scaling your voice AI to production can directly be shown with some recent examples. Taco Bell rolled out an agentic voice AI to its drive-thru ordering system last year. And as people do, they tried to break it. A man ordered 18,000 waters, and the system choked trying to process it, stalled mid-order until staff had to step in. It went viral, but not in the way that Taco Bell really wanted. And afterwards, they moved to a more flexible setup. Franchisees decide when to use the voice AI, and the busiest locations lean back on humans. The model here isn't the part that glitched out. It did exactly what a helpful assistant is supposed to do, take the requests of the customer. It's just that nobody told it that some requests deserve a second look before being fulfilled. That's a guardrails failure, and that's the first of the 4 things we'll get into. But it's not just food chains learning this the hard way. Air Canada's chatbot told a customer flying for his grandmother's funeral that he could claim the bereavement discount after he traveled. The real policy said the opposite: apply before you fly, not after. So he flew, then he tried to claim it exactly as the bot told him to, but Air Canada refused because that's not their policy. And the case went to a tribunal where Air Canada argued that the chatbot was responsible for its own words as a separate entity. In the end, Air Canada lost this case and had to pay the fare difference. Again, it's not the model here that made the mistake. It gave a fluent and confident answer. It's just that it wasn't checked against its actual policy. And we're not trying to throw anyone under the bus here, but we want to give examples of the 4 key pillars that we try to keep in mind when we make that step from a fancy demo to production. So saying make the agent behave isn't really exactly one point, and it's a bunch of different issues. So when we take voice AI from an MVP into production, we have to pay close attention to these, and these 4 are the 4 pillars that I've seen have the most impact when moving to production. So guardrails is the answer to the question, what can the model say? It's a real-time check happening while the model speaks on what the agent is doing, judged against a set of rules automatically by another model. So it's there to catch conversation drift right as it happens and steer it back to what you're actually paying the model to do or to handle. It's also there to pick up and stop prompt injection attempts. So it's there to protect the rules that your agent was set up to follow. And thirdly, it's also to manage what topics your agent should avoid, or should talk about and should avoid. So this goes from making sure your agent doesn't produce poems making fun of your own company, which has happened, down to preventing it from giving medical or legal advice. And the advice I'm giving here is blunt. You need guardrails for anything public-facing. The cost of doing that is negligible compared to the cost of dealing with the issues caused by when these things don't get caught. Moving on to security. And this is really the question of who is allowed to do what is the agent allowed to do when. So the obvious fix that people start with is to just tell the model in the prompt. That's how we interact with these LLMs. So never change a shipping address without verifying the user. That is simply not enough in production. Some actions are irreversible, and the cost of making a mistake can be high. So generative AI models, in their nature, are non-deterministic, and asking a model to judge authentication non-deterministically is not enough. So privileged conversation paths sit behind a hard, structured gate. Only once we have clear confirmation from a tool that credentials match and we're talking to the correct user, do we, for example, allow a system to change a shipping address. Account number, postcode, 3 attempts, and if it locks and we still can't make it work, we escalate the issue. Don't let the AI decide on the fly. Now, onto grounding. And this is kind of the question of where do our facts come from, and links to the 2 cases I showed before. So the common pattern that we see people start off with here is you paste your entire 20-page returns policy into the prompt and then say, make no mistakes. When I was working in a call center myself as a student, we didn't get a book and were told to remember all the policy. And we shouldn't expect AI to do this either. We were taught how to find the right information quickly and accurately. And that's also what we make the AI do. So for questions like, how do I initiate a refund? AI models are very capable of searching over chunks of information at a time and finding the right answer. Don't bombard your model with all the information it should remember at once. Rather point it to where it can look for it and search in it. And then for exact values, it needs to get it right all the time, deterministically. So again, don't let a non-deterministic model handle it. Give it deterministic tools to fetch the real data. So in practice, a phone number that almost matches or an address where one digit is swapped, that's the kind of issues that accidentally cause a returns policy to be 40 days instead of 30 days. Make sure you give the model deterministic tools to give deterministic answers. And last but not least, evaluation. This answers how can we ensure and also enhance quality. So the obvious assumption here is simple. We set up tests. If it passes all our tests, it's ready. But again, that is not enough in production. What's important is that these standards that we want the model to achieve are agreed upon beforehand, so that when deadline pressure comes, for example, we know that we don't have evaluation drifts. We compare every single stage in our development to the same set of standards as at the beginning. And then what's really important is that we evaluate every call. There is AI automation in place. We can evaluate every single call automatically and use all of this data. You're generating free data that you can use to improve your models. Use it. And then lastly, passing a test isn't proof. I've talked a lot about determinism. Models are not deterministic. So passing a test once, that's a good signal, but you need to keep testing. So even once you've deployed, keep testing, keep the evaluations going so that you can observe when the system stops working suddenly. To give you a tangible example, on average, we've seen this path take around 12 weeks. Exploration comes first. Most teams treat this proof of concept there that we see in step 2 as step 1, but it isn't. Step 1 is really figuring out if you have a high-value use case that's even worth chasing. So your transcripts, your CRM integration, you need every piece of data that you can integrate and see if you have a use case that the AI can actually help you with. Then, once we do make that decision for no or no-go, we can then start building. So then we have a 2 to 3 week period of validating a minimal viable product. Does our model perform how we expect it to? And can we convince users and gain their trust in the system? Then, importantly, comes the step that I've been talking about a lot, and that is moving to production. And then this can take usually between 5 and 7 weeks. So we integrate with your real system, we handle calls that the MVP also didn't see, and we prove that it holds up at real volumes. And then it doesn't stop there, importantly. Optimization and handover keep going after that on purpose, because you want to monitor how your system performs over time, and ideally also improve it and keep it up to date, so that your team can own this and evolve it also once we are no longer in the room.
All right, thanks again. That was packed with information and was very, very clear. Thanks for that. We covered a lot of ground, but we see already in the chat a lot of questions coming in, and we're going to tackle those in just a second. To me, still the most exciting part is that this is still the worst form of voice AI that we're going to see. It's only going to get better. So I can't even imagine what ElevenLabs V4 is going to look like and what we're going to be able to do with that. We're going to change the setup just a bit to be able to tackle all of those questions efficiently. I want to thank you already for joining us, and we'll see you in a second.
All right. I think all of my speakers are seated and we are ready to tackle some questions. Some of them have come through, and I suggest to just tackle those chronologically. I'm guessing this one is a bit more for you, Ryan. We have Louisa asking, for something like a shipping address change or a refund, how much do you trust the AI to decide who it is talking to?
Yeah, that's a bit of a trick question, I would say, because we don't really. So verifying who someone is happens through a hard system check. So it's not something that we like to leave to the model's judgment. The first question when we build systems like this is always, is this behavior something that the client is comfortable handing over to an AI agent? And then if yes, we do have the tools to support that. So yeah, I would say like sensitive actions that sit behind this like gate that I was talking about, those really come into like hard-coded verification. And so we have different kind of levels of verification strength we use for that. So like really secure paths, we have like strong verification. So things like one-time passwords that the agent can, programmatically, generate and then send to the caller via SMS or email, for example. And then the AI verifies it just like it does for an invoice number, for example. And then for slightly more frictionless and less critical verification, we can rely on things like knowledge-based authentication. So that's what you commonly see, where the agent is confirming things that the customer or user should already know. So things like birth dates or postal codes. And then we also, with that, build with that limit. So that's what I just mentioned recently with the 3 failed attempts. So if after 3 failed attempts it still doesn't really work, we do escalate to a human rather than letting the AI keep guessing or, move on just for the sake of moving on.
Yeah. Okay. So many different options for each use case and whatever the needs might be. Okay. Good to know. A second one, and I think this relates to this previous one, actually, all those guardrails that you put into place to make sure that you get quality. Does that not slow down performance too much? And what about the extra costs that it might bring?
Yeah, there's a real trade-off here, but I think it's one that's worth making. So there's different kinds of these guardrails that we can use. So there's these like blocking checks, which do add a small amount of latency. So yeah, roughly speaking, you can imagine like 200 to 500 milliseconds of delay. And that's because the full response by the agent gets reviewed before it's spoken. That's like the most secure guardrail we can really think of. And for most customer experience flows, that delay is not really noticeable. But for something that's more time sensitive, we do also have the option of having like a midstream check instead that like checks as the model is speaking whether what it is saying is good to pass on. So yeah, performance-wise, in terms of latency, a small hit, but nothing too bad, and there's options. And then for the cost angle, so because these guardrails are a second AI model call that's like layered into the conversation, it does add some costs, but honestly, this is a very negligible cost because this model is often very lightweight and really cheap. So it has a very narrow scope of just classifying is this safe or not. And that makes it a lot cheaper than all of the other models that are actually involved in a system like this. So from a cost perspective, it's not really something that adds a noticeable effect to your bottom line. Okay. And then what's I think good to mention is that we don't run these guardrails on every possible step. So it's also checking, is this like, do we need to run this guardrail in this point in the conversation? So you don't do unnecessary checks throughout that, that are not relevant.
Yeah, and maybe one thing to add, we've just launched a new feature, which is essentially a separate dedicated security model that checks for off topics like manipulation attempts. And since this is running in parallel, it is designed to not add any additional latency and also is part of the platform cost. So both in terms of latency and cost, it's optimized.
All right, thanks. That's the cost side. Perhaps we also have a question from Lander. Jens, if you could tackle that one. Could you give an example of how you calculate the savings and the gains for such a use case? So not sure if there's anything that is not too confidential that we can share.
Yeah, Indeed, depends, of course, on the confidentiality on what we can share. And of course, the obvious question is it very much depends on the use case. And our goal is, of course, in the first interactions that we have with you to already start and define how that should look like. But to just give some basic example, right? If we look at the inbound calls, so where we do an intake, let's assume a customer maybe has 25,000 calls a year, an average duration of 12 minutes of a call, which doesn't seem too unrealistic. Of course, you have scenarios, right? As we said, you could do a scenario where you only do the intake, you help with the identification of the customer, where you would typically already save around 3 to 5 minutes. Definitely if there's complex names, complex reasons, or complex numbers to get right. 2, for example, a fully contained call where you even help with frequently asked questions, answering them, or even to more extent, helping them with, for example, more personalized questions about their account. In the lowest range scenario, you could maybe save, like I said, 3 to 5 minutes. In the more extreme case, where we go even further, up to 12 minutes. Now, if you do a quick math on the average labor costs that we have in Belgium, then you could easily already save in the lowest scenario up to 150,000 on yearly cost savings, and in the higher scenario up to 350,000. And that's only, of course, mentioning the cost for pure time that humans are not spending in the call, or human agents. It's not taking even in account yet the handling time that they have after the call, preparing and further fixing the CRM tickets. It's not taking account all the positive monetary gains that you have from the improved customer experience and so on. So there is definitely a business gain that is always more positive than the cost for it. And even to go a little bit further on maybe an outbound example, so where voice AI helps with the outbound case. Even there, we typically see, if we take the example from the example that we gave in the webinar, which is the calling out to overdue customers. We saw in a typical use case that there is a 75% lowering cost per call. So typically we have costs for a call that could be up to 40 cents per call, which go now down to 10% per call. And also recovery rates there went up from 10% to 16%. So 16% more people that actually paid their invoices, which was only 10% in the starting case. So of course, depends on the use case and the volumes, but the savings and the use case is definitely there, and always is bigger than the cost in the examples that we saw.
All right, thanks for sharing. We have one final question in the Q&A section here. If any more questions come to mind, please do post them. Maurits asks, what are still bottlenecks in just the voice user experience, both for ML6 and ElevenLabs? And perhaps Thomas, I'll start with you. Any known bottlenecks still?
I wouldn't call them bottlenecks, but certainly something we keep optimizing, right? So it's obviously the pronunciation, the accuracy in technical domains with brand-specific terms. Of course, we're also continuously optimizing the latency, specifically when it comes to connecting knowledge bases or tool calling. And then, of course, also specifically for Belgium, making sure that the dialect coverage is accurate and natural. And then on top of that, of course, we're continuously optimizing for the experience itself, right? So think of the turn taking in the conversation, if the customer interrupts the agent, and also if the customer is in a noisy environment, like all these things we're essentially continuously optimizing, but I wouldn't call them bottlenecks. I think bottlenecks are typically when, for example, the data is not clear, right? The data is not optimized that the agent is supposed to use, and the process for the agent to go through if the customer has a specific request. If those things are not clear, then obviously the agent can't handle them well. But yeah, that's where I would see bottlenecks.
All right, Jens, anything to add to that?
Yeah, and of course, like we mentioned, the voice user experience planning and all the process is also indeed mapping out together with the customer what is the journey on the phone that we want to guide the customer through. But also thinking about specific complexities of voice. Like we said before, you don't necessarily want to have a full, let's say 10 pages policy as an answer that you could get with ChatGPT or similar. You want to have it in very digestible nuggets. Also, for example, we think about if you want to do a number identification, which is typically also a link to the CRM and so on, this can take slightly longer. There, in that case, we want, for example, that the voice bot doesn't start speaking too soon, because you might have yourself a hesitation when pronouncing certain numbers. So that's something in the journey that we have to take in account. Also, like we said, for example, with a chatbot, you would typically want a quick summary of like, got what you meant, this is what you were meaning, right? Based on that, this is your answer. Where again, you don't want to get a summary of what you just said every time on the voice. It's perceived completely differently. So those are typical things in the, let's say, voice user experience and the journey that you also need to map out in the functional design phase at the start together with the customer.
All right, thank you. Just coming back to the main thesis that we started this webinar with, that the technology is now ready for production. We have experienced that. Ryan, you mentioned that some parts of it will always be non-deterministic because you want to involve those language models. How do you then ever tell the client, like, yes, this is ready to go live?
Yeah, I think that really depends on what I discussed as well with the evaluation criteria that you agree upon before. So when we start this process of developing such a tool with a client, we really always make sure that we agree before the build phase what our evaluation criteria are. And then it goes back to this always be testing that I was talking about. So we do then automatically score every single call as like a success or failure. And then we also set up evaluation suites with simulation tests for edge cases, or also deterministic tests for the agentic tool usage, for example, so that we can confirm that our model behaves as we want it to. And then we monitor this performance over time during the testing and deployment phase. And then we also make sure to deploy in stages. So if our evaluations are consistently above those predefined thresholds, then I think we are confident that the system will also hold up and is ready to go live. But this question of are we ready to go live is really only ever as good as the evaluation harness that we set up. So it's also something that we really emphasize the importance of whenever we have projects with clients. And that's also the nice thing with ElevenLabs, that there are such extensive tools and products available there that really cover the wide range of different tests that we do need to cover for this. And then I think it's also still important to notice in the end, systems can still fail. And just like with human agents, it's also part of a working and performing system that we have the tools to monitor and then also react and deploy fixes quickly.
All right, thank you. We are running out of time. I see perhaps one final question for you, Thomas. ElevenLabs version 4, when can we expect it? And can ML6 have some early access?
I can't put a hard date. It's always hard to do in research. But I can promise that as soon as we have something concrete, ML6 will be the first to get access to it.
That is good to hear. Good to hear. All right. Thank you, everyone, for joining and the interesting questions that were asked. We do have a lot more content on voice on our website. In fact, a new blog post on voice went live this very morning, so do check that out. If you have any other questions, do not hesitate to contact us through the website. This webinar will also be available very soon in its entirety on our YouTube channel. And on that channel, you can also find the previous webinar on AI strategy and the 5 key questions you should be asking within your company at the C-level, as well as the do's and don'ts of making your company AI native. I can highly recommend that. With that, have a nice rest of the day, and we hope to see you at our next webinar, which will be announced very soon.